A signal. A signal is defined as a physical quantity. It is a physical quantity that varies with the time independent variable or space or any other independent variable. For example, ambient temperature, if you consider, let us record the ambient temperature from morning 6 a.m. to evening 6 p.m. It varies like this. The 12 noon, it is very high. So here, the physical quantity is temperature. Temperature that varies with respect to independent variable time t. This variation of this physical quantity, temperature, is called signal. So how it can be represented? T, that is the temperature, equal to some function of time independent variable t. Why it is called independent variable? You cannot control time. It is varying irrespective of variation of the physical quantity. That's why it is independent variable. Space also independent variable. No one can change it. So a variable which cannot be controlled are called independent variable. So the t equal to f of t. That is temperature equal to function of time. Depends upon the time, it varies. So a signal is defined as a physical quantity that varies with respect to independent variable time t. In this case, signal modeling. The signal can be represented as x of t is a signal. X is dependent variable, t is independent variable. So x is function of t can be written like this. X of t means t is independent variable, x is dependent variable. Here we are representing x as function of t. So this can be written as a is constant sine omega t. Omega also a constant, a also constant. T is independent variable. As t varies, this signal varies. So if we plot this, the signal is looking like this. Sinusoidal signal, a sine omega t. So this is x of t. It is plotted versus time independent variable t. So this is mathematically represented as a sine omega t. That is called signal modeling. Another signal, x of t, can be written as t square. X of t equal to root t. X of t equal to 2t plus 5t square. So as t varies, the value of x changes. So these are all called deterministic signal because they can be expressed mathematically. On the other hand, random signal means it cannot be represented mathematically. For example, the previous, the temperature we have seen, this cannot be represented mathematically. It can be recorded, but cannot be represented mathematically, but can be predicted, but we cannot obtain the exact mathematical model. That's why it is a random signal. It is a random signal which has no mathematical expression, means random signal. So the signal which has mathematical expression means that is deterministic signal. Now let us further classify the signal as continuous time signal, discrete time signal, and digital signal. Continuous time signal means the temperature is an example. The sinusoidal wave is an example. Here it is continuously available. This signal is continuously available. At any point of time, the value is available. That's why it is called continuous time signal. On the other hand, the signal is not continuous means For example, I am depositing money every month. 0th month, I deposited some amount. First month, I deposited some amount. Second month, I deposited some amount. Third month, I deposited some amount. So these are all available only at this instant. At the first month, a particular day, first day, let us say. So it is available. On the other day, there is no deposit. So this type of signal is called discrete time signal. This is a natural discrete time signal. On the other hand, we can obtain a discrete time signal from continuous time signal. That is also possible. That is also possible. For example, if temperature already we recorded, what is at 6 a.m. what is the temperature? At 7 a.m. what is the temperature? At 8 a.m. what is the temperature? At etc. At 12 noon what is the temperature? At 1 o'clock what is the temperature? 2 o'clock. At 6 o'clock what is the temperature? Every 1 hour the temperature is recorded. Then it is called discrete time signal. These are all values taken from the continuous signal. So we are sampling the signal at every 1 hour. Every 1 hour, we got the signal. So we got the value. And so this signal is temperature is available at n equal to 0, 1, 2, 3, etc. T equal to 1 hour. 1 hour. So when n equal to 0, T of 0. T of 0 is here. T of 0, here it is 1, it is 2. And at T of 0 means at 6 a.m., what is the temperature? At 7 o'clock, what is the temperature? When n equal to 1 and T equal to 1 hour, that's why that is also 1. Therefore, T of 1 equal to what is the temperature? 20.02, 21.03. And T of 3 equal to 22.45, like that. The instant, n is represent the instant at which the sample is made. 0th instant, first instant, second instant, third instant. So n is an integer. T is interval, sampling period or interval. So we are sampling every 1 hour. Therefore, T equal to here, T equal to 1 hour. T equal to 1 hour. Then it is called discrete time signal. These are all called discrete time signal or sampled signal, because we are sampling. It is not naturally discrete signal. It is sampled the continuous time signal. That's why it is called sampled signal or discrete time signal. Now, suppose we are representing the temperature by using only 2 digits. 2 digits only. Then T of 0 equal to what? 20. T of 1 equal to 21. T of 3 equal to 22. Like that we got. Then it is called quantized. Quantized. Here, the minimum value that can be represented by this quantization is 1. Therefore, here the quantization is 1. Quantization is 1. Suppose we want to represent one more decimal place, means T naught equal to 22.4, T1 equal to 20.0, T3 equal to 22, T naught equal to 20.0, and T1 equal to 20.0, T3 equal to 22.4, T3 equal to 22.4. Here, the quantization scale is 0.1. So the smallest value that can be quantized is 0.1. Therefore, the quantization scale is 0.1. In the previously, the minimum lowest value that can be represented in this method is 1. Therefore, quantization scale is 1. Suppose if you want to represent 22.45 means the quantization scale is 0.01 because smallest value that can be represented in the quantization is 0.01. Therefore, we can, if the quantization scale is 0.01 means we can represent T naught equal to 20.02, T1 equal to T of 1 equal to 20.03 and T of 3 equal to 22.45. Like that we can represent. If the quantization scale is 0.01, then it is called digital signal. Quantized discrete time signal is called digital signal. In practice, digital signals are represented mostly by binary signal zeros and ones.